All right, class, good Monday morning. Or is it just, oh, sorry, it is Wednesday, sorry. I'm a day off. Let's go with it here. So we learned some rules for logs. We got rule number 1, number 2, number 3, number 4, number 5, number 6. What we want to do here is to change all these rules into the natural log function as well. We're good? So we got any base that we like besides 1, all the positive numbers besides 1, and we're going to introduce this special one. So E, we learned last time. I'm off, Owen, I'm off. Last week we learned it was 2.71828, right? What we want to do here is we want to convert all our rules into the ln function. He's about a question. Why there's an n inside there? It's actually just an acronym for, it's called the natural log function. So it's abbreviations of the word. Next question. Next question should be, how come the L is first in the N instead of the N in the L? Here's the French mathematicians that invented this. So they always do everything backwards. So when they say it's log of the natural, instead of natural log, we say natural log, but it's log of the natural functions. So they abbreviated L and then N. Okay, I guess we'll go with it. So real quick here, log base E is really the same thing as ln of x. So rule number 1, let's go back in our notes. Dunk, dunk. Log base E of E or ln. Let's convert this real quickly here. So the rule here is log base B of B is equal to 1. Good. As we convert this, this would be log base E of E is equal to 1. But then we don't like to write it that way. Whenever we see ln log E, we're going to replace it with ln. So this technically is ln of x equals 1. Are we good? Here's our little rule. Sorry. I'm still waking up here. How about that? Better? So ln of E is 1. They cancel each other out. That's kind of what happens. You have an ln function, you have an E function. They cancel. Next rule, let's go with it here. Number 2. We'll go back in our notes. This one is log base B of B to the x is equal to x. Let's see, you guys, real quick. Can you guys go from first rule down to the second rule right away? Can you guys do that? Instead of having this intermediate step right here. If we need to do the intermediate step, that's fine too. Log base E, E to the x is equal to x, and ln of E to the x equals x. That's my next rule. Third rule, okay, this is log base B of 1 is equal to 0. This one we should be able to convert. Can you guys convert directly to the rule? Instead of the intermediate step, what would that be? I'll go with that. ln 1 equal to 0. Three rules down, 3 rules to go. And go back here for this little rule A. So tell me if I'm going too fast. We're good? I want to make sure you guys write these down. Rule number 4 is we got this big old base called A. Of x is equal to x. There it is. do you guys say? Do we need an intermediate step? Uh-huh. Go ahead as well.
And then in like superscript, I guess, ln of x.
Perfect. Okay. We're going to use that from time to time right there. Number 6, almost on number 5, sorry. ln 10.
Why does E replace B in some of them and then that one replace A?
We use different variables.
Oh, okay. So A and B are interchangeable.
Uh-huh. As far as rules are concerned, yeah, if they become inside a problem. Number 5 was just the definition of. Number 5 was just this definition of, I kind of included in there here, of base 10 as the default base. So we don't need to do rule 5. We're going to go to rule 6 here real quick here. Rule 6 is log, we'll go back here, log base A of y, log base A of x, and those both equal each other. So if that's true, then this is true. Y equals x. That's the rule. That's the original rule in terms of logs. Boom. In terms of natural log, what do you guys say?
Ln x equals ln y.
So if that's true, then that is true. So there's my final rule right there. Okay, with that said, guess what we're gonna do? Everything we've done in 3.2, we're gonna do it all over again. Instead of having like log of 4 or log of 3 or log of 10 or log of 2, we're gonna have ln. So same stuff all over again, let's go. So do you guys remember example 1 was write the logarithmic equation in exponential form? Same thing here. Can you write this logarithmic expression in exponential form? I was doing the trigonometry here, that's why.
Did you zoom in on the column?
Oh, absolutely. 2 of them. How about that? For you guys to write them down, all yours. And I'll look at something real quickly here. All right, with these ones, a little bit more trickier because it's E and it's a decimal approximation. So it's negative 0.916 approximately. Good. That's the little approximate thing. Okay, that's AB, and there's C right over here. Ooh, that's a little definition. Let's see how we can convert it from logarithmic form to exponential form. So let's see. I think we should be able to finish. Hey, okay, that'd be cool. Okay, jamming, we good? So let's see, go from logarithmic equation to exponential form. So it looks like whenever I do this, I always think about what's my base? My base is E, my exponent. Dot, it's approximately, and the answer, done. We good? We're just changing forms. All yours for B and C. So again, we're doing everything we did in 3.2 just with base E now. So we're going to change forms. we're going to simplify, and we're going to graph. And also real quick here, I know I didn't check grades here this week here, but everybody turned in their test corrections to me, is that right? Just make sure you don't have them. Okay. Ooh, thank you so much, Maddie. Ask me right after class. That's right. I never, because you're absent that day, right?
Yeah.
Yeah, so
Oh, Mommy, what did I keep saying?
let's go with it. E to the 6.520 dot is approximately 679. Okay, log L, so that means this is going to be true or not true? I think so, true, right? Boom, there it is. It's true in exponential form. Okay, let's go the other way. So this is log form into exponential form. Got a few people still copying it down. Go for it. Cool, okay, you good there? Tell me if you guys need more time, it's no problem. Camille, what's up?
When will we have our first test?
Say it again.
When will we have our first test?
For this semester. I'm thinking probably the week following.
Not this week, but next week?
Not
Not the
next
next
week,
week,
but
but next
the week
next
after that for sure, yeah. And I'm
We'll have it
almost,
after we get the midterm, right?
we will, yeah.
So probably a Wednesday of the week after next, because
Okay.
we don't want a Friday test.
Yeah, so I give you the Monday afterwards, yeah.
It's a Monday. Okay.
All right, let me go with this one here. Let's go back the other way.
Uh-oh.
Right, the exponential form and logarithmic form, and then we'll get to other stuff.
I'll just ask him to explain it to me. What did exactly do with it?
And you guys talk, let's see, the video that we saw last time, did that make sense to you guys, what logs were invented, why?
Made a lot of sense, actually.
Yeah. I got half the people saying, yes, that totally, they're like, I have no
I don't
clue.
remember watching.
It put it into context, like, it was kind of just like this, I didn't really know what to do with the information when bringing just the context to it.
Okay. Cool, yeah. It was made to multiply big humongous numbers together. So 5,684 times 12,728. What would that be? Go. And then with logs, you can actually, instead of multiplying every single number, you get a slide rule. And you would take those two numbers, you put them on a slide, and you're good to go.
But now slide rules are like obsolete, right?
Uh-huh.
You can just use a calculator.
Mm-hmm. I should bring it. I gotta find it. It's somewhere in my boxes here. My trigonometry teacher. My trigonometry teacher. When I was in school, I think it was like a raffle or something. We did like a fun little thing, and I won the TI. I think it's called 10X. It was the first TI calculator that came out, and it's a green screen. You have the buttons, the thingamajig is green. Because the screens used to be green back then. I'm gonna find it somewhere. It was a cool little thing. And he said 1970s, when it just first came out, it was selling for about $300. That's what it was on the market, because that was the new thing. Don't need a slide rule. It does all this stuff for you.
You got it for free, but when you come in, you trade on.
Were you always as good as math in high school as you are now, or?
No, better. Hopefully I'm better.
Well, but I mean, like, were you always like just naturally good at math?
Oh, somewhat, yeah. I think so, yeah. Even though I didn't get to calculus, I didn't get to calculus in high school. The furthest I reached was trigonometry.
Did slope up like a grade ahead? Math.
Normally, yeah, you guys usually should all get to calc. Mhm.
Especially because we can choose that.
All right, B and C, all yours to copy them down.
Well, we don't have to. We should.
Yeah, that's right, for classes for next year here, are you guys doing, is it geostats, the second part of geostats or no?
It's
We have to take it again?
It's either geostats or trigonometry, I think. I think we might have.
Is neither an option?
Okay,
I probably don't.
Can we not do it?
I just probably get around it.
No, we can't do geometry, we just have to.
I've heard grunt and size about trig, but at the same time, I don't want to be in another class with Dr. Ring, so I don't know. I don't know what options.
you got it.
Well, you know, my semester.
Yeah. We just took. That's all this.
Do I want the class that I know is difficult or the teacher that I know is difficult? It's a big question.
All right, class, let's go. Let's see, I'm gonna convert this to ln of, oh, ln of 7 point, why am I? Is that right?
Yeah, that's right.
Yeah, 7 point, thank you. Boom, approximately, right? The dot, dot, dot. Yeah, what exponent do you put on 2 to give you 7.3? It's about 2. Owen, checking me just to make sure.
Yeah, you're right.
Oh, sorry guys, real quick here. This is, that's exponential form. This is still log form. I messed up.
Okay, I was a bit confused.
Yeah, sorry, this is a log form. That's not exponential form. Can we,
Dropped the E in that one, but not in the one before that.
how come I dropped which one?
There's no E in your answer,
Uh-huh,
but there was in the ones before.
over here?
And on the last page, there was answer said E in it.
We're doing the opposite, right? We're going from.
We're going
Oh,
opposite,
that
yeah.
makes sense. That makes sense.
Yeah, so all these should have LNs inside them, and I messed up, class. I messed up with B, so I'm gonna take that out. It should not have an LN inside. It should have been an exponential form. So this one would have been LN of 3 is equal to 2x. We good? So the stuff that's equal to goes inside the LN. The exponent goes to the outside. Okay, so thought for the day. You guys ready? Notice what happens here. See this little 2x? Now that came to the outside. Are we good? Wasn't 2x an exponent before? Yeah, this little 2, isn't this 2 an exponent? And now ln of this, all that stuff equals to 2. We good? So crazy thought. You guys ready for this? Logs are exponents. Just to tweak your brain.
So the number that goes next to the log, it's not like the base, is it exponent also?
So when you change forms, notice, yeah, that comes across as just being equal to log, right? So we think of this right here.
The log equation is finding exponents, but is the log itself?
Yeah, because you go like this. You say, what's log base 10 of 100, right? What's this, right? But then that is equal to what exponent do you put on 10 to give you 100?
No, 1, 2.
2. Yeah.
I know.
So notice there's an equal sign. These two are exactly the same, right? So if I say log base this of that, I'm really technically talking about an exponent. It's kind of like the best way to do it is dollar bill, right? Dollar bill in the front of it, there's a, who's on the dollar bill? George Washington? All right, yeah. So you got George Washington's face, right? You say, hey, that's a dollar bill, right? And you flip it over, and there is, what's in the back of the dollar bill?
No, it's like the triangle thing. Hold up.
Okay, the triangle thing is on one side, and the middle of it is, I think it's a Lincoln Memorial, isn't it? is on the back of a dollar bill?
That's the 5.
That's what's on the back of a dollar.
Oh, okay, it just says 1, that's right. So the triangle thing on one side and then the eagle holding stuff on the other.
I use my hair straightener and I straighten them out.
Oh my god.
What a psychopath.
Wait, hold up, that works?
I mean, people are taking my money, so. Also, they all get like really nice ones for our tips at work, so you get all the nice dollar bills.
That's cool.
You
That
just
went
put
a
it on
different
the lowest
direction.
setting and you straighten your dollar bills and then they're all nice and crispy.
Some people like that, that's
Just
cool
use a
too.
clothes iron, it's easy.
Okay, we good there? So logs are exponents. Kind of keep that in the back of your head here as we do these. All right, so let's do the same stuff we did with regular logs here. We're gonna do kind of quickly. So not 3 examples per each one, but maybe like 1, maybe 2 examples per each one. And then we should be able to do the rest of the homework here. So we have to use a calculator. You should be able to find an LN button on your calculator somewhere.
Log button on the calculator? 'Cause I
Hey.
cannot find it.
That's true. Let's go. Let's
There
jump.
has to be, I just can't find it.
It's right above the, LN.
I have a TI 89.
I have a TI-84, so yours should.
Aren't all the calculators just numbers on it?
Okay, well, you have an LN.
Yeah, I know, I found the LN and I was like, that's not.
You know, I'm just saying, the calculator on my phone works perfectly well for this.
That's cool.
I don't know how to use my calculator.
Oh.
The stuff that you showed us in class, I have too many buttons.
Okay, sounds good. I'll help you with it. So before, it should be similar. So the buttons, so let's go with it.
Not mine.
Why are you missing the
Uh-huh.
logs?
Let's do this one, Owen, and then you tell me if you need some help with it, okay? So let's go with it. This is, use a calculator to evaluate this. So 3 ln of x, and we're gonna stuff 0.32 into that x. So now, let me just write it out here, first of all. So the way you write it out is this way right here. The x has to go into the f function. I think that's the way I have it on the test. It's f, find the f of 0.32, and then you plug it in like that, and you're gonna punch that into a calculator here.
Which
So-
side do you punch in?
It's
The second side?
How do you get the
Right
F?
on the- No, you don't have to put the
You need an
whatever,
F,
you
though.
just do 3 LN and then it.
So,
you automatically
three.
There is an LN button.
Yeah, you should find an ln button, and on top of it somewhere, you should find e to the x button, because they are inverses of each other. Anybody, real quick, raise your hand if you find a log button in your calculator. Log,
No, it's
think mine
not.
has.
not on yours, okay.
No, it's not there. I had that one problem on the home.
Got you, okay, I'll help you with it. And then you should find on top of the log button, e 10 to the x, because that's your base. Okay.
The hard thing is, I couldn't figure out how to get it to graph.
Oh.
Oh, okay.
I know, but every time I did that, it says syntax.
Ah,
It doesn't matter what I type in, I can type in like x equals y and it's still.
oh, and I'll help you through it here towards the end of class. Maybe we should have some time. Okay, class, are we good there? It's negative 4.348. Cool. Let's do 3 decimal places. That's the way it is on the homework as well. So -3. Oh. -3.4. I think it's 418. Is that right? Just making sure. 418. Yep. 3 decimal place accuracy on this one here. And I will help you guys with your calculators towards the end. I think we should have some time. Okay, evaluate. Okay, are we good there with this one? Just a quick one. Actually, no, let's take the time right now. Oh, and let me see your calculator just real quickly. Those of you who want to start on this one now without a calculator. Ooh, crazy stuff.
Without a, uh-oh.
Could you zoom in on that?
Yep, yep.
I'm watching.
Gee,
There you go.
Oh,
Uh-oh.
yeah. Oh, lovely.
No, hold on. Sorry, guys. I think something is wrong here. Oh, no. Let's see. Yeah, so we're gonna plug that into the calculator. Oh, let me check. Are we able to do that?
That probably, yeah, okay, so go to one. So we can just go to the, so see here, this is the numbers to make.
E negative 5 divided by e to the negative 2 times 5 divided by 3x. Right, but we're just evaluating g of x equals ln x. Like, I know. It doesn't matter. It doesn't have to make sense, we just have to do it.
Oh, they're actually great.
Okay, ask me if you have any other
We know
issues
that,
with it, okay?
It's like, there was.
ln x equals negative 5 halves.
Okay, we're good to go with this one? Find the answer of, so let's go with it here. So this is g of x. We have ln of x as our function, and our x is this right here. So we're gonna take this little value here, we're gonna plug it into the ln. So in this case, it's gonna be g of x is equal to ln of x. If that is the case, then g of e to the negative 5 halves makes ln of e to the negative 5 halves. Now, anybody know any property that can help us with this guy? Math is good. Which property of math?
Division.
I don't know.
Is this a close one?
Let's take a look at our properties. Yep. Take a look at one of your 6 properties.
It's the second one.
Oh, one of the.
Isn't it?
Yeah.
And answer is.
How do you go from step 1 to step 2?
How do you go from step 1? Here's step 1.
No, from like the, from x equals e to the negative 5 second. How do you go from that to that?
Oh, okay. So the x gets replaced with e to the negative 2y. So this x gets replaced with the same exact value.
So in like the first one, where
Oh.
where would you is the second line of stuff right correlated to the first line? Like is that from the first line? Or is that just what you plug in?
Just what you plug in. Yeah, just what you're plugging in. So the plug-in value is e to the negative 5 halves. And let's do another one just to make sure we got this as well here. Okay, we're good? What happens to ln and e? Going back to our rules somewhere over here. It's either this one, any one of those rules fit. Oh yeah, it's rule 2. Whenever you have ln and e, they will undo each other's work. And you could just put x, absolutely.
X. The answer would be negative 5 whatever.
Perfect. It is negative 5 halves. Good there. So let's do one more easier one here. How about this? X, give me.
We just go straight to the answer negative 1.5.
Yes, yeah, as long as you know that, in the textbook, I didn't do a great job of bringing you to understand. You should sort of see this right here. This is what you want to see. You want to see a ln and e close together. You're taking ln of e. In fact, when we start, I'll even tell you to do this here. Just cross these out right here because those undo each other's work. So ln button of an e button and negative 1.5. Is it useful? Yes. When we start solving equations, we're going to try to get to this point so we can cross them out. Okay. Let's see how we're doing here. I think we're still doing good. Okay, let's jam. They're good. So evaluations here, let's jump to, hey, all right. Some graphs here. So let's do, first of all, before we get to this graph here, let's do an initial graph of ln of x. If we remembered back to what we used to do, right? This jumped to become 1, 0, is that right? For regular logs. And then this one's going to be the value, the base, comma 1. So this is going to be, the next value is going to be 2.7, comma 1. That's going to be our next dot. Oh, real quick here on your calculators, can you guys do this for me? Just do e to the 1, first of all, just make sure we got our calculator. You can find what's e to the 1. Okay, then do this one for me. 1 divided by e to the 1. 367, yeah. So in terms of graph purposes, we're going to go with 0.4. We're good. It's just kind of easier. With the other one, we do 2.7, just to the nearest 10. You're not going to get more accuracy than that. So our 3 dots that we were concerned about is 1, 0, 2.7, comma 1, and 0.4, comma negative 1. There's your 3, we call them critical points for this graph. And remember, ln function goes like this, turns and goes like that, right? And then we have a vertical asymptote that comes down like this. There's my original graph. That's the one that we should have memorized. That's the one we should know really quick here how to get, and these 3 points memorized. Now the question is this. So this guy is h is equal to ln of x. So now let's jump to our problem here. Can you tell me, or can you sketch this graph? Based upon that graph, can you sketch this one? Notice we're not going back to our exponential functions anymore, right? We're trying to stick with our log functions here. So what does the x plus 1 do? Ooh, I think, yeah, the up one would be on the outside.
Right. No, but left, yeah.
Good, yep. Inside the function, it's always the opposite, right? So if it's a plus 1, we go left. So in this case, our graph would be, in fact, it's probably easier to do the vertical asymptote. Let's put the vertical asymptote down at x equals negative 1. They have to scoot these guys over real quickly here. So instead of 0.4, oh, sorry, it's not, it's 0.4 or 0.4. Sorry, class, real quick, just make sure I got this. Let me put 0.4 because it'll be easier to think about. All right, you all, what happens here when you scoot this back 1 unit? Okay, yeah, this 1, 0, that's the easy one. 1, 0 becomes 0, 0. That's nice. Okay, 2.7, comma 1 now became 1.7, comma 1. And the fun one, 0.4 became negative 0.6, right? Because negative numbers are going to work the opposite direction here. So this one's going to become negative 0.6, comma negative 1. And there it is. There's my graph. Oh, I forgot to put a little dot there. Boom. I need domain. I need x-intercept. I need vertical asymptote. Or VA, I guess. Yeah, VA. And that's it here. So boom. Let's see. Who's been most quiet that I can bug? Tristan, what's my domain? Is there any graph that you don't see? Like, or is a graph across everything? This is definitely a little starting point, huh? Because when you're going from here, there's no graph here, right? Until you get to -1, right? Anything after -1, there's a graph. In fact, right at -1, there's still no graph. So it can go like this. Parentheses, we're not including the -1, but then we go off to positive infinity. Are we good there? I don't want to just bug people. I mean, we have to go in order. I guess we have to go in order. But Tristan, I just want to bug just for bugging him. Isabel, what is my x-intercept? Cool. Yeah, you can say x equals 0, or you can say 0, 0. Just works just fine. And Dylan, all yours. What's my equation for my Dylan row 1? What's my equation for my vertical asymptote?
I haven't quite figured that out yet.
On the graph itself, you should be able to figure out this little line right
Pretty
here.
sure the asymptote is.
Y-axis was originally, right? And then what we did is we scooted it back 1 unit. -1, awesome. Okay, good? Awesome, okay. Let's do this here. So this is by hand. This is the hand drawing for us, right? So now get out your calculators. And now let's see if we can graph it on a calculator. So I need to graph 3 ln of x minus 1. Let me graph it. Here's your, here you go, Abe. It's the next problem over.
Oh, okay, I was like, wait, did I miss something?
Using a graphing utility to graph this function right here.
So whenever you press ln, it immediately goes to parentheses. Does that change it?
Perfect. No, it just means it wants to know what the x is. And as soon as you plug in the x, then you close out that parenthesis, because that -1 has to be on the outside.
Oh.
So the way you would graph it, probably put it in on the calculator, you can put 3 ln. As soon as you press this button, little parenthesis opens up. You're going to press x. You have to close off this parenthesis, because if you don't, then the x minus 1 becomes all inside there. And you got -1. And real quick here, da, 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 da. Look at this. How many need a calculator? 1, 2, see. I got it all figured out here. I stayed a little later. I got it. Charlie. Finally got it. Finally got batteries for it. It's all yours. You can give them back to me at the end of class, but then you have them for anyone for class. Oh, sorry. Landon, you good? You got 82. We good? Yep. Okay, everybody else has calculators, so hopefully. Jamming. Okay. Tristan, you have a calculator?
What's that?
Okay, just bring it next time. It would be cool. Okay. And Annette, you have a graphing calculator or just regular calculator? Okay, it does graphs, yeah? It does graphing, sorry? Okay, sounds good. So let's put this in here. So you're gonna put 3 ln, you're gonna open up, the parenthesis opens up automatically. Oh, Camille, I missed you there. Do you have a graphing calculator that you can bring sometime?
No.
No, okay.
I have one that I'll end up bringing.
Okay, then we'll take on. Okay, wanna make sure everybody's taken care of.
Thanks.
So close the parentheses, you subtract 1 afterwards, and let's go with it here. Keep, jam to this right here. I'm going to turn it on. Landon, yours is going to look just a tiny bit different, but it's still going to be similar. So y equals button right over here. I got 3, I got ln, have the x inside there, close off the ln, and -1 from it. Okay, and then at that point, click the graph button, and you're good to go. Okay, what do we expect to see? We should expect to see it still coming off of the y-axis, right? Because of the just ln of x. We should see it going up 3 times faster, so not as flat, but 3 times faster. And then we should expect it be went down just a little bit here. Let's do this here. Let's go back to the previous problem. Can you guys do, oh, any issues with this one? Just want to make sure. Any issues? Anybody did not get this graph?
I can't find the LN button.
It's to the left of the 4.
Yeah.
Oh, just look at it.
The E to the.
No, just
You can spell it with the.
Oh, it's on the actual one.
Okay, so yours doesn't have the X, so you have to include your X on X. No problem, no problem. This is like,
Alpha.
and I want to see if it graph.
Enter.
Enter first.
Enter.
And then just enter and then graph. And then you should see, bam, okay.
Yeah.
All right, good. Let me walk around, just make sure.
So you hit the yellow button when you hit the letters. Hit this second, and then hit alpha. And then pause it. Yeah, and then you can just type.
Normal button.
I guess they just
My
explained
name
it.
is yours into this one first and then do it.
Tell me next time.
True.
When you don't have what else?
Yeah.
Okay, anybody else need to?
My name also equals
Isn't there? LN right there? For this build up, X in there. Pulls off the difference. And minus one. If you click negative one, if you go to negative one, then you
Want to graph the letter.
negative one, that's minus.
I graphed the letter. It's made a line. Wait. What if I didn't graph A plus 1? Will that give me?
Don't break it, it's not yours.
I graphed A.
Don't judge me.
The TI, if I remember correctly here, the TI.
This is what I
Does not have it directly, because we use LN all the time in mathematics, which then you're gonna put catalog. Good?
Yeah, no.
You got any good catalog? It
Yeah.
opens up every
Yeah.
single function you have.
Okay, you ready?
You just have to knock it over here.
Why would you want to torture yourself?
And you go down, or you go to MF.
Why does it get it like an answer? I don't know.
Seen a TI.
I broke that.
And then you can do
I mean, you didn't break it, you just didn't do it right.
No, I'm pretty sure it's
So you're
broken.
gonna have to go through the catalog.
What, did you try to zero divided by zero or something?
No, it's like that.
That's
but
why.
Many different variations.
Or.
We, by the time we get to calculus, we don't do log, we use LN almost all the time, like 99% of the time is LN. Every once in a while, you might get log base 3 or log base 10 to do some stuff, but other than that, we don't use it.
Or whether or not they've actually had 80-something variations of the TI calculators, or did they just start using the number 80 at some point?
Yeah, I'm not sure why the 80. Yeah.
Like, how many calculators have they made?
Well, yeah, 82, 83, 84, and then 84 has a whole bunch of variations because they finally realized they can put so much memory in it. They can do expandable memory. They can
Yeah.
say it went berserk. And then TI 89 is the one that's kind of higher in mathematics. Class, I think, let's see, time-wise, we have to almost be done. So that we learn how to graph it, let me just check real quick here. We just need to learn how to solve them, and then let's do this one real quick here. This will be the last one, and think you guys from here, you guys can do the homework here. Use the one-to-one properties, solve this. So you have log on one side, you have log on the other. Are they the same base?
Yeah.
Ah, yes, they are the same base.
Base, yes.
Yeah, because there is no base listed, therefore the base is 10 on both of them. So what we do, technically, if you want to, you can go like this. You can cross them out. And then what you here, and then what you do is you actually do the problem itself. So subtract 3 from both sides, gets you a 9, divide by 5, gets you 9/5. Dun, 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 dun. And we solve for x. This is the first part of the equations we're going to solve. So next one, in 3.3, we're going to take a look at more properties for logs. 3.4, then to solve a whole bunch of different equations. That's what we want to do. And the fun video we'll save for Friday. We'll save the one.
Why is it that when I put in this equation, it gives me